homogeneous equation. In this video, I will explain you how to solve an ordinary differential equation that is homogeneous in nature. Means we are going to solve a homogeneous ordinary differential equation. Previously, I told you a method of solving the ordinary differential equation that was the separable equation method. Now we will see that if any equation is not separable, then how we can solve it. For that purpose, you have to check whether the given equation is homogeneous or not. The first step to solve the differential equation, the ordinary differential equation, is you have to check that whether the equation is separable or not. Like for example, you have an equation dy by dx equals x over y square. Now you see that you can separate the variables y on one side and x on other side. How you can solve it? You can just rearrange it to get y square dy equals x dx. So if you observe that we have easily separated the y variable on one side and x variable on other side. If we can get this separated variables on both sides of equation, then we can say like it is a separable equation. For separable equation, there is a simple and easiest method that is given in another video of separable equation method. What you will do, you will just integrate both sides and you will get the solution. But what will happen if you don't have a separable equation? You cannot separate the x and y variable on one side. Then what you will do? You will move on to the second method, that is for the homogeneous equation. And what you will do? You will just observe, you will just check whether the given differential equation is homogeneous or not. For that purpose, you must know that what homogeneous equation exactly means. Homogeneous equation is defined as if f of xy, the function that is a variable of x and y, is homogeneous if you replace your x with tx and you replace your y with ty, and you get this kind of equation. The t variable is separated from this function. If it is t variable, t is completely separated from your main function, then we can say like the given function is homogeneous. For example, your given function is x cube plus y cube plus xy square. Just replace your x with tx and replace your y with ty. You will get here tx whole cube plus ty whole cube plus tx and ty whole square. X with tx and y with ty. Now rearrange it. After rearranging and after simplification, we will get here t cube x cube plus t cube y cube plus t cube xy square. Now make this t as common. You can get back x cube plus y cube plus xy square. Now you can easily observe that if you separated the t from there, you got the function back. So it means this function is homogeneous in nature. And whatever power you will get here, that will be, this n will be your degree of homogeneous equation. That n is the degree of homogeneous equation. Now I think you know very well how you can figure out whether your given function is homogeneous or not. So let's move on to the example of solving the ordinary differential equation that is homogeneous in nature. Homogeneous also means that the degree must be same throughout the function. If you don't want to follow this lengthy method of figuring out that whether it is homogeneous or not, you can directly figure it out from your equation as well. That the degree must be the same throughout the function. You see here, the degree is 3 here, the degree is 3 here, and down 2 plus 1, the degree is also 3 here, and also 1 plus 2 is 3. So you see the degree is same throughout. So it means the function is homogeneous in nature. Also, you cannot separate the variables, x variables on one side and y variables on other side. So it means this is not a separable equation. Now it is not separable. So the second step, you have to check its homogeneity. The degree is homogeneous, so it means this is your homogeneous equation. If it is a homogeneous equation, then how you will solve it? I will show you. For example, you are given with the differential equation dy by dx equals x cube plus y cube divided by x square y plus xy square. Name it as equation number 1. Equation 1 is homogeneous. So, by substitution, what substitution you will have here? The substitution will be y equals vx. Now you have to substitute every time for the homogeneous equation y equals vx. Now take the derivative on both sides with respect to x. I will get here dy by dx equals. Now the derivative of x will be 1 and v will come as it is. I am using the product rule here. V will come as it is and the derivative of x will be 1. Plus, now x will come as it is and the derivative of v will be dv by dx. Now, you have to use this substitution in your this equation number 1. So if you use this substitution in your equation number 1, you will get here, in place of dy by dx, replace this value. That will be v plus x dv by dx equals, now basically I am moving from x and y variable to v and y variable. Okay, in place of x cube, it will remain as it is, plus y cube will be v cube x cube divided by x square as it is and y will be vx plus x as it is and y square will be v square x square. Now I will get here v plus x dv by dx equals x cube plus v cube x cube divided by, I will get here x cube v plus x cube v square. Now you can see that I can take x cube common. After taking x cube common, I will cancel it with the denominator as well. So after taking x cube common and cancellation, I will get here 1 plus v cube over v plus v square. Now simply, now you can separate this equation. After this substitution, your equation will necessarily be converted into the separable equation. So you have to basically now focus on what? Separate the x variable on one side and the v variable on the other side. You will get here x dv by dx, move this v on the other side. This will be 1 plus v cube over v plus v square minus v here. Now simplify it. After simplification and taking LCM, you will get here, my equation was x dv by dx equals 1 plus v cube over v plus v square minus v. After simplification of this step, I will get here x dv by dx equals 1 minus v over v. Now I can separate my dv with this v variables and x on the other side. Move this v variable on the left side. I will get here v over 1 minus v dv equal, move this dx on the other side and this x here, I will get here 1 over x. Now this is your separable equation. So you can just integrate both sides. So what I will do, integrating both sides, I will get here v over 1 minus v dv equals integration 1 over x dx. So from here I can simplify it like, I can make this denominator upside like how? Just write negative sign, negative v. I am making the same thing upward in the numerator. Integration of 1 over x dx will be your ln of x. Okay, now I can write here 1 as well. How I can write 1? If I write 1 here, then I need to subtract the 1 as well. So now you can separate the two things. The first thing is this one and the second thing is this one. So I will get here negative 1 minus v over 1 minus v dv, negative minus 1 over 1 minus v dv equals to ln of x. From here I got integration of dv minus minus plus integration of 1 minus v dv equals to ln of x. So from here I got minus v plus this function. This one will give me the integration as minus, this is 1 minus v, so it will be negative ln of 1 minus v equals to I can write it ln of x plus constant of integration as ln of c. Now I can move my this terms to the other side as minus of v equals ln of 1 minus v plus ln of x plus ln of c. Now this is the property of ln. You can just write these functions in multiplication with one ln. That will become ln of x 1 minus v into c. Now, what was our substitution at the start? Our substitution was y is equals to vx. Now separate v from here. If I separate v from here, I will get y over x. So just replace your v with y over x. Here. Replace back, substitute back. I will get here minus y over x equals ln of x into 1 minus y over x c this term. Now just rearrange it. I will get here minus y over x equals ln of x into 1 minus y over x times c. Now I can remove this ln. How? Just taking exponential on both sides. Just take exponential on both sides. It will become this thing. Now this ln and e are empty of themselves, so that can be cancelled out. So I will get here e raised to power minus y over x equals x times 1 minus y over x times c. Now just multiply it inside. I will get e raised to power minus y over x equals x minus y into c. So this is the solution for this homogeneous differential equation. I hope you like this video. For more methods of the ordinary differential equations, you need to subscribe the channel to get the updates.